Okay, so let's starting the new lesson, right? Let's start the new lesson. Then write down the heading. Okay, write down the heading. Remainder theorem. Remainder theorem. Right? Remainder theorem. Comma. Factor theorem. Factor theorem. And algorithm of division. And algorithm of division. Right? Okay. Here we have three right topics right under the one lesson. Okay. It's very important thing because this is right first question right we study in the A-level grade. Right? It is right pure mathematics. Right? The first paper we have right pure mathematics. Question number 11, part A or B. Right? One of the part. Okay? Right? Then here we have 80 marks out of 1000. Right? Okay? Then 75 to 90 out of 1000. Right? You know that we have a final marks, right, for the 1000, right? Then out of 1000, we have marks in between 75 and 90, right, given the examination. And also is a major question of your term test, right? But we don't know, right? Okay, if you can write the how many term tests in the schools, right? We don't know, right? Just grab me. Factor theorem, sorry, remainder theorem, comma factor theorem, and algorithm of division. Okay. Remainder theorem, factor theorem, and algorithm of division. Right? There is a background of this topic. Okay. Right? Then also here including the some parts of the previous lesson. Right? Here the long division. Right? Long division, and also the functions. Right? Okay. The idea of the function. Right? So we need to know. So there have new students. Then I right think all right see the recordings. Right? Watch the recording. Right? Then they have some problem. Please let me know. Right? Okay. Here we have new students. Then I think so. You follow the recording. Right? If you have any doubt or anything to know, then please tell me. Right? Okay, you can use in the chat and also the right microphone. Then you can talk. Okay? Right? Then follow it. Okay. So okay. Then write down the subheading. Right? Write down subheading. Remainder theorem. Right? Remainder theorem. Okay. Remainder theorem. Then here we need to know how we find the remainders, right? When the polynomial divide by another polynomial, right? Okay, here we need to know, right, how we taken the remainders, right, how we taken the remainders when the polynomial divide by another polynomial, but they have some specialties, right? Okay, they have some specialties because we know a method to get the remainder, right? What is that method? Okay, generally it's okay, doesn't matter, right? So right, then I ask what? Okay, we have a method now to find a remainder when the polynomial divide by another polynomial. What is that? Right? Here's what is the method we can follow to get the remainder? Just tell me. Right. Yes, same sir. It is what? Long division. Next, we have one of the method is a long division. Right? Long division. So, right, then we can follow the long division to get the remainders, right, of any polynomial divided by the any polynomial. But okay, it's okay, right, doesn't matter. Okay, then here we have the theorem, right? Here we have a theorem. We can use that theorem. We can get some remainders, right? We can get some remainders. Not all the remainders, any polynomial divided by any of the polynomial, right? They have a limitation. It is what? Any polynomial divided by a linear polynomial, right? Any polynomial divided by linear polynomial. What is a linear? Yes. What is a linear? Huh? What is a linear meaning? Yes. In the first day of the polynomial functions, we talk about what is a linear. What's a linear function? Yes. Right. What is a linear function? Yeah. What is a linear function? Where are the answers? What is a linear function? That is a linear. Yes, we can tell that. Okay. So, what is the expression? Right? Expression ax plus b form. Ax plus b. Ne? Or we can write the ax plus b like that. Ne? Right? Then what's that? It is a power 1. Ne? If the x is the power 1, then we call that it is a linear. Right? Then what happening there? Function, right? Function divided by the linear function, then we can get the remainder. Okay, right? That is a specialty here. They have a limitation. What? Which limitation? We cannot obtain all of the remainders, right? Function divided by the another polynomial, right? It's given only, right? The remainders, the function divided by the linear function. Okay, function divided by the linear function, right? Okay, now we write the right theorem. Okay, then you write the subheading, right? Remainder theorem, right? Under it we need to write the theorem because this theorem we need to state in the examinations, right? We need to state in our words, okay, and also need to prove, right? Okay, then you need to know very well this, right? Then write down the right theorem. Okay, if any polynomial function fx if any polynomial function fx, if any polynomial function fx divided by x minus a, x minus a, x minus a, x minus a, then the remainder is f of a, f of a, the remainder is f of a, right, f of a, where a is a constant, where a is a constant, okay, where a is a constant, right, okay. Now what's that? If any polynomial function fx divided by x minus a, then the remainder is f of a, right, then the remainder is f of a, right. Any polynomial function fx divided by x minus a, then the remainder is fa, right. Now you can mix your words, right, get the image that fx divided by this, remainder is fa, right, remainder is fa, okay. We need to, right, get that, okay, and put your words, right. That is, we need to give us the clear idea of the theorem, right, in your words, doesn't matter, right, doesn't need to follow my words, okay, right. When you given the correct, right, idea, it's okay, right, okay, right. Then that is the idea. What function need to divide by the linear function? It is x minus a type, so the remainder is fa. A is right, constant. Then what is this a? What is this a? Yes, what is this a? How we taken that a? How we taken that a? They have a method. Then we call that this is the divisor. Okay, here divisor, right? Okay, this is a dividend. Okay, right? It's a dividend. So they have a divisor. This divisor is x minus a. Then we equal that divisor to 0. Then what is the value of x? Right? Okay. Then it is a divisor. Then this divisor equal to 0. Then what is the values of x? We can take that value of x, right? Value of x. We need to substitute to the function, right? Then x equal to a of the fx is given to fa, right? Okay. Then we have fx is 2x minus 1. Then what is the meaning about the f1? What's the meaning about the f1? Yes? What's the meaning about the f1? Yes? What's the meaning about the f1? F1 is right? Substitute x equal 1 to this function, right? Then x equal 1 is 2 times 1 minus 1 is f1. Then what is f minus 2? Right? Like that f minus 2 means, right? We need to substitute 2 times minus 2 minus 1. Right? Then this x values need to substitute there. Okay? right? That is a FA, right? Then A is a any value. Okay, A is any value. How we taken that A, right? Then divisor equal to 0. That, right? X value taken there. We need to substitute to the function, right? Okay. Now you have a clear idea what is that. Okay, what is that? Now we come to the proof. Okay, we come to the proof. Write down proof. In the examination, we need to know this, huh? Okay. When we come to proof, right? What is here? We have fx divided by the x minus a, right? How we can write it? We know that dividend equal divisor times quotient plus remainder. We talk about this in the first lesson. Right? Dividend equal divisor times quotient plus remainder. Now what is the dividend? Is fx. Divisor is x minus a. Quotient is qx plus remainder we take as the r. Okay. Now we need to get the r and fx relation. Okay. If we need to get the r and fx relation, so we need to remove this entire part. Okay. We need to remove this entire part. So if we need to remove it, right? Only a method, right? We can make 0 here. Right? We can make 0 here. Then x minus a becomes 0, right? For some x, right? We can remove this part. For that, I substitute x equal a here. Then f of a equal here a minus a q a plus r. Now what's happened? A minus a is 0. Then 0 times anything is 0. Therefore, right, fa equal r. Then what is the r? Is the remainder. Then remainder equals fa. Right? Okay, that is the proof. Right? That is the proof. Okay? Right. Right now. Okay, finish. Now you need to write these 2-3 times and take into mind. Okay, how we prove this? Okay, how we prove this? Okay, right? Because right in between 1 or 2 minutes we need to write this. Okay, if you not remember, we can't do this. Okay, they have some proof. We need to know very well. Then we need to practice to write that. Okay, otherwise we can't write the proof. Okay, right? Then here we need to make the practice. More practice given the good result. Okay, more practice given the good result. Okay, right? Then that is the way. Division equal divisor times quotient plus remainder. Then we substitute that and also substitute x equal a. Then we can get the relation of fa and r. Then r is the remainder, so it's equal to fa. Right? Okay, that is the right proof. Now we come to the questions. Right? Now we come to the questions. Right. Let's see. Okay. Then we have fx equal 2x square when fx divided by x minus 1 find the remainder. Okay, right? If x minus right fx is given is a 2x square plus 3x minus 1. Okay, write down the first question. Fx equal 2x square plus 3x minus 1. When fx divided by the x minus 1, find the remainder. Right? Find the remainder. Now this is the question. Now we need to know, right, which steps we need to write in the examinations, right? Because otherwise we can't get the full marks for you, right? Then you need to know, right, how we write the right answer, right, to take the full marks. Okay, right? Then you need to know this. Okay, right? Let's see. Now I write the first answer. Okay, because you don't know it, right? So you need to follow that. Okay, after the questions there, right? First of all, here, first of all, I write the theorem, right? Which theorem we use here, right? And how we can get the remainder. Okay, right? How the remainder can be taken using the right theorem. Okay, right? Why that? However, we write fx right divided by x minus 1, right? The remainder is right. Now we have fx, right? We write that fx divided by x minus 1. This is a division. This is a x minus a type. Okay, x minus a here. Then it is x minus 1. The remainder is. So by the remainder theorem, we can write what is the remainder now. What is the remainder? Yes. What's the remainder? Yes, Chinuli says minus 1. The answer says 1. Okay, right. Do you have any other answers? Himara also 1. I ask him what is the remainder now. Okay. By the remainder theorem, how we write it? By the remainder theorem, how we write it? Yes. Yes. Where are my other students? Senya, Pasindu, Hikmeni, Himaya, Janvi. Yes, Mahisha, this is F1. Okay. Let me Ashan, Mansika, Sanket, Gallery, Insara, Pawan, Sasnika, Nara, Nirmal, Namsuka, Shomika. Yes, all of you are. Yes, Gallery also says F1. Mahisha also says F1. Others? Yes. Yes, what is? What is the remainder? Huh? Then what I say? Fx divided by x minus a. The remainder is what? Remainder is f of a. Neither. Right? By the remainder theorem, we write the remainder is f of a. Right? By the remainder theorem, we write the remainder is f of a. Now here, what is the a? Right? When we take the divisor x minus 1 is equal to 0, then x equal 1. Right? Now 1 not a remainder. F1 is a remainder. Okay, F1 is a remainder. Got it? How we write it? F1. Then we write it. We have 5 marks. Okay? Right? If we are identifying the remainder using the remainder theorem, we give the 5 marks. Right? Then you need to state. Otherwise, you have a clear idea right about this. Right? We give the 5 marks. Right? It's clear if you write it. Okay? Right? Like that, we have a F1 is taken to the theorem. Now we need to get the F1. However, we write the Fx is 2x squared plus 3x minus 1. Now we substitute x equal 1. Then F1 equals 2 times 1, 3 times 1 minus 1. Okay. Here 2 plus 3 is a 5 minus 1 is a 4. Right? It's a 4. Then I write that therefore remainder equal 4. Okay? What is that? It's a rough one. Okay? It's a rough one. Doesn't need to write. Okay? You can write taken in your mind. Okay? Right? So that is the way we write the answer. First of all, we state the theorem. Right? Not the theorem. Right? How we use the theorem. Okay? And after we write the function and substitute that value. Okay? And take the answer. Okay? Right. Write down. Write down. here tell me it's okay, but we have some problem. Okay, we have some problem. We cannot using the long division, right? That's why, okay, we explain the remainder theorem. Otherwise, we don't know remainder, right? Doesn't need to write remainder theorem. Here given the simply the question like that, okay, right? If they are not state the using only a remainder theorem, right? We can use in the long division to get the remainders. Doesn't matter, right? Okay, in this lesson, right, we have right some theories we need to know that, but okay, we can using any alternative methods, right, get the answers. They are not given right specific method. Okay, right, right. Now that is the way we need to write the answer, right? However, right, we state the theorem, right? What is fx divided by x minus 1? The remainder is f1 is taken to the remainder theorem, right? It is like this a, right? Then how we identify the a, right? X minus 1 equal to 0, then x equal a is a 1, right? Then we write the function and we substitute, right, which values for the x and substitute and get the answer, and finally we write the what's the remainder. Okay, right, that is the thing. Now we write the second question. Okay, second question, find the remainders. Okay, find the remainders. Right, find the remainders of the following. Here's the first one. Fx equal x cube minus 4x plus 2 divided by the x minus 2. Right, x minus 2. Second one, fx equal x cube minus you need to write the answer one by one. Okay. right? Then you state the right remainder theorem, how we taken the remainder, and write the function and write which one we substitute and simplify and get the answer. Okay, hurry up now. Right. So let's start the discussion. Okay. Using whiteboard. So here, first of all, we write the theorem. Fx, right? Fx divided by x minus 2, the remainder is f minus 1. This is a f2. F is a f2. Okay, right? The remainder is f2, right? Okay. Now we write fx. With fx equal x square minus 4x plus 2, right? Then we substitute x equal to 2. Then f2, 2 squared, 4 times 2 plus 2. 4 minus 8 plus 2 is a minus 2. Therefore, remainder equal to minus 2. Okay? Like that we can write the answer. Okay? Now we come to the second one. We write it fx divided by x plus 1. The remainder is f of minus 1. F of minus 1. Okay? Okay, f of minus 1. So we write the fx x cubed minus 3x squared plus 4x minus 2. Then we substitute x equal minus 1, f minus 1 equal minus 1 cube. Then substitute correctly and take the correct values. 4 times minus 1 minus 2. Here we have minus 1, minus 3, minus 4, minus 2. Right, then minus 10. Therefore, remainder equal minus 10. Okay. We come to the third one. Here I write that fx divided by x minus 3. The remainder is f3. How we taken it? x minus 3 equal to 0, then x equal 3. Next, right? Then we write the fx is 2x cube minus 4x plus 3. Now we substitute x equal 3 here. Then f3 equal 2 times 3 cube 4 times 3 plus 3. Then here 3 cube is 27 times 2 54 minus 12 plus 3. Then 57, 55, 45 is 45. Therefore, remainder equal 45. Okay. Fourth one, fx divided by x plus 3. The remainder is f minus 3. Is f minus 3. Then fx equal x cube 5x squared minus 5. Here we substitute x equal minus 3. Then f minus 3 equal minus 3 cube plus 5 times minus 3 square minus 5 minus 27 5 times 9 minus 5 minus 32 plus 45 13. Remainder equal 30. Okay. Right. Then we come to the last one, is the fifth. Right? Fifth, we write the fx divided by x plus 2. The remainder is f minus 2. What is fx? X to the power 4, 2x squared minus 3x plus 1. Then we substitute this generally. And the question 4. This was 7 generally. x cube plus 5x squared minus 5. Check that. If we are write the x squared, here x cube, right? X cube plus 5x squared minus 5. Okay, doesn't matter if you have right problem. Okay, so here we substitute. Doesn't matter if you have it out, please let me know, right? F minus 2 equal minus 2 to the power 4, 2 times minus 2 to the power 2, 3 times minus 2 plus 1 is 16 plus 8 plus 6 plus 1 is 31. Plus 5x squared. Here we have x cube plus 5x squared minus 5. Finally. Okay. Plus 5x squared. Then we substitute x equal minus 3. Okay. Right. Then these are the remainders. All I got this? Raise your hand. Who got the answers? Yes? Raise your hand, raise your hand. Shubhilka, with me, Namsuka, Awan, Sanket, what happened? Yes? With me, Namsuka and Pawan. Now get the values, what's happening? Right. Okay. So you need to get the values, okay? Okay. Now we write the next question. Question number 3. Q3. Okay. Write down. Let fx equal x cube plus 2x squared plus ax minus 3. Okay. Let fx equal x cube plus 2x squared plus ax minus 3. When fx divided by x plus 1, the remainder is minus 5. Minus 5. Find the value of simple A. Find the value of simple A. Right. Now try this. Now try this. Now you have answer question like this. They have unknown, right? We need to find the unknown value. Right. Now let's see how we write the answer. Okay? How we write the answer. Now look at here. Right? Now here also we write the statement we write. Okay? Fx divided by x plus 1. The remainder is f minus 1. By the remainder theorem, we take as f minus 1. Okay, but it's given. What is that? F minus 1 equal to minus 5. Next, f minus 1 equal to minus 5. Okay, now where we have f minus 1, we can replace it and equal to minus 5. Now we write the fx equal x cube plus 2x squared plus ax minus 3. Then we substitute x equal minus 1, f minus 1 equal minus 1 cube plus 2x squared. 2 times minus 1 squared plus a times minus 1 minus 3. Now it can be equal to, right, the given value minus 5, because why? It is f minus 1, in the left side we have f minus 1, it is minus 5. Now we have equation. Right? We not write this. Here the minus 1 plus 2 minus 8 minus 3 equal minus 1. Okay. Now we simplify it. Here the minus a minus 2 equal minus 5. Then minus a equal minus 3. A equal plus 3. Here we need to get the a only. Then, right? That is a way. Here also we state the right remainder theorem. Right? How we taken the remainder. Okay. What's happened, Janvi? Not heard my sound. Okay. Right. So now we move to the next question. Right. It is that question number 4. Right. Question number 4. Write down it. Let fx equal ax cube plus 2x squared plus bx minus 3. Fx divided by x minus 1 and x plus 2. The remainders are minus 3 and minus 3. Okay. Both remainders are same. Right. Respectively. Find a and b. Right. Now hurry up. If they have a one divisor, right, or any other divisors, we need to follow the same thing. Yeah, both remainders are same, minus 3. Okay, right. Let's say here we can write the theorem together. However, fx divided by x minus 1 and x plus 2. Okay. The remainders are f1 and f minus 2. f1 is given minus 3 and f minus 2 is also minus 1. Like that we can write. Okay, or you can write this separately. Now we write the fx is ax cube 2x squared dx minus 3. Now we substitute x equal 1, f1 equal a plus 2 plus b minus 3 is equal to minus 3. Then we can form the equation a plus b equal, here minus 3 cancel, minus 2 is the first one. Okay, right? We need to get the right some right equations. Now also we substitute x equal minus 2. Okay, so f minus 2 equal, here a times minus 2 cube 2 times minus 2 square b times minus 2 minus 3, right? Okay, then it is minus 3 equal, here minus 8 plus 8 minus 2b minus 3. Here we have equation 8a plus 2b equal 8, and also we can divide by the 2, 4a plus b equal 4. This is the second one. Okay, now we have two equations, a plus b equal minus 2 and 4a plus b equal 4. Then now we need to solve these two simultaneously, right? Need to get the a and b. So however we taken the 2 minus 1 implies b cancel, 3a equal 6, a equal 2. We can substitute 1 by 1, 2 plus b equal minus 2, b equal minus 2. Okay, got that? Raise your hand. Raise your hand, who got that? Yes. Then 11, 12. What's happening in the others? Do you have a trouble? Yes. If you have a trouble, please let me know. and also you need to take mind, right? Because right, this question very important, right? We need to get the full marks for here. Okay. If you have any doubt, please let me know. Huh? Right. Now, take the corrections. Hurry up. Okay. Right. Finish it. Who need the time? Raise your hand. Right. Now we come to the question number 5. Right. Question number 5. Okay. Hurry up. Finish it. Yeah. Right. So one student finish. Right. Two students finished. When we start the discussion, here we write the fx, right? Fx divided by x minus 1, x plus 2 and x minus 3. The remainders are f1 is given minus 6, f minus 2 equal 0 and f3 equal 6. Right. Now we can substitute the values and form the equations. Here we write the fx ax cube bx squared cx minus 6. Now we substitute 1. f1 equal a plus b plus c minus 6 equal minus 6. Then a plus b plus c equal 0 is a question. Substitute x equal 1, x equal minus 2, f minus 2 equal, here minus 8a, I write the answer, plus 4b minus 2c minus 6 equals 0. Then we can divide by 2, minus 4a plus 2b minus c equal 3 is the second one. Now we substitute x equal 3, f3 equal 27a 9b 3c minus 6 equals 60. So it can be divided by the 3, 9a plus 3b plus c equal 22. is the third one. Now we have three equations, 1, 2 and 3. We know the method, right, how to solve three variable simultaneous equations. Right? We know very well how we solve the three variable simultaneous equations. Right? Then what is the method? If we consider 2 by 2, if we consider 2 by 2 and make the another two equations. Here easily we can remove C, then I get the 1 and 2 addition. 1 plus 2. 1 plus 2 implies, then using the 1 and 2, C cancel, minus 3A, right, plus 3B, C cancel, 3 plus 0 also 3. Then we can divide by the 3, minus A plus B equal 1 is the fourth one. And using the 2 and 3 or 1 and 3, we need to build another one. Then using the 1 and 3, again, no, 2 and 3. Right? 2 plus 3 because plus C and minus C cancel easily. Then 2 plus 3 implies. Then 4A, 5A remain. 2B and 3B also 5B. C remove. 3 and 22 is 25. This can be divided by the 5. A plus B equal 5 is the fifth one. Okay. If you are suppose the any other two, right, you have a different, right, equations. Okay. In here, minus A plus B equal 1 and A plus B equal 5. Okay. Now we need to solve these two. Okay. We need to solve these two. So we can get the 4 plus 5. 4 plus 5 implies, right, here A cancel, 2B equals 6, B equal 3 by 4 minus A plus 3 equal 1, then A equal 2, B equal 3, A equal 2. Now we can use the first one to get the C. Right? First one to get the C. When we substitute to the first one, right, A equal 2 and B equal 3, then C become a minus 5. C become a minus 5. Then I write there by 1, C equal minus A minus B, then minus 2 minus 3 is a minus 5. These are the values of A, B, C. Okay. Right. Who got the answers? Raise your hands. Okay. What happened to the others? If you have taken the correct right? First three equations. Others taken the first three equations correctly. Raise your hands. Who got the correct equations? Hola. Good. Right? Then you need to solve this correctly because we have enough knowledge to that. Okay? Right? You know about that very well. Okay. Right. Then that is a remainder theorem. Okay, that is a remainder theorem. Now, right, the last few questions, right, last two questions we using the remainder theorem and find the unknowns. Okay, so like that we need to get the values. Okay, like that we need to get the some unknown values. Right now. For that we cannot use the long division. For that type of the questions we cannot use in the long division. That's why we need to remainder theorem. That's why we need to remainder theorem. Okay, got it that? Right. Now we come to the next one. Now we come to the next question. Sorry. Next theorem. Okay. Write down. Factor theorem. Factor theorem. Okay. Now we come to the factor theorem. Write down the factor theorem. Okay. So now tell me, we know the factorization. We have the quadratic function. We know the factorization. But we have a cubic function, the power greater than 2. The x cube term, for the x to the power 4 function, the 4 polynomial, we cannot take the that factors. We can't take the factors. So, for that we need to follow this factor theorem. There have some limitations. There have some limitations. If they are given any polynomial, we cannot get the all factors. Okay, because it's hard. Okay, there have some okay, factors is 2x minus 1, 3x plus 1. Okay, like that. Okay, minus x minus 4, x plus 5, like that. Okay, this can be generated the polynomial. However, we can't get the all factors, but we have some knowledge to get the factors in the limitations. What is that? Here we have some limitation. Then I explain after this. What is now? We need to write the factor theorem. What is the factor theorem? Okay, what is given there? Okay, what's given there? We need to identify. Okay, then write down. If any polynomial fx, okay, this is a theorem, if any polynomial fx f of a equals 0. F of a equals 0. If any polynomial fx, f of a equals 0. Where simple a is a constant. A is a constant. Right? F of a equals 0. A is a constant. Then x minus a, then x minus a is a x minus a is a factor of fx. Factor of fx. Okay, right? What's happening? Here we have a function fx, right? Here we have a function fx. Then we can identify, right, a constant a, right? We can identify constant a, right? That a substitute to the function fa, right? Fa. So what is the fa? What is fa? Yes, what is fa? By the previous theorem. Yes, what is fa? Fa is a what? A remainder when the fx divided by the x minus a. Okay, right? Fx divided by the x minus a. Fa is the remainder n. Right? Fa is the remainder n. Huh? Then that remainder equals 0. Then we know about that. This remainder becomes 0 means it is a factor. Right? It is a factor. So, right, fa equals 0, then x minus a is a factor of fx. Right? Then we have any polynomial fx. Okay? Any polynomial fx. Like that. 2x square minus 3x plus 1. Here we identify simple a. It is a constant. Right? Then you substitute value f1. 2 minus 3 plus 1 is equal to 0. Right? But we substitute 2. Right? What happened? 8 minus 6 plus 1 not equal 0. Right? Then what happened? If we can identify some value a, right, it's become a 0. It's become a 0. Right? Then we can tell that what is a factor? Factor is x minus a. Right? How we write it? Right? We write that value, right, with the x, right, with the minus 1. X minus 1 is a factor. Okay? Right? Then if we have f minus 2 equals 0, right? In some function, f minus 2 equals 0, then what is the factor? Tell me. Some of the functions, right? Okay, if we have taken some function, then f minus 2 equals 0. Then what is the factor? Yes, what is the factor? X Yes. X minus minus 2. Doesn't need to write like that. It is a what? X plus 2. X plus 2. Now x plus 2 is a factor. Okay. Then f3 equals 0. F3 equals 0. What is the factor? F3 equals 0. What is the factor? Yes. Yeah, it is x minus 3. X minus 3 is a factor. Okay, there I have a minus value, it's write the plus with the x. There I have a plus value, it's write the minus with the x. We can write the factors. Then x plus 2, write x minus 3, write x plus 1, x minus 1, like that. Okay, so here we need to think what we need to identify, right? What is the a? What is the a here? Okay, we need to substitute. What is the a? Here we need to substitute. Right? In this syllabus, right? Okay, in this syllabus, we need to substitute to a only the 6 values. Right? That is the limitation. Right? Only we have 6 values to substitute. Right? That's our minus 3, minus 2, minus 1, 1, 2 and 3. Minus 3, minus 2, minus 1, 1, 2 and 3. Only 6 values. Right? That 6 only we need to substitute. Okay, that 6 only we need to substitute. Then we identify whose becomes 0 and write that. Okay, if we are doing the rough work here, right? If we substitute that 6 values, one of the 6 values, right? Okay, separately, then identify who given the 0, right? Then we can get the answers. Got it? Right? Got it that? Like this. If we identify 0, then we substitute and tell that this one becomes 0. Therefore, x minus a is a factor. Clear that? Okay? Clear? How we get the factors here? Right? Which terms we need to substitute there? Right? Only 6 values we need to substitute. It's a minus 6, 3 to plus 3, right? Positive value. Sorry, right? Whole values. Okay, minus 3, minus 2, minus 1, 1, 2 and 3. No any fractional values, no any decimal values. Okay, right? That is the way we identify the factors. Right? Okay, got it that? Got it? Right. Then that is a factor theorem. Now, right, let's see how we use it and get the factors. Okay. Right. First question. Find the factors of fx equal x squared minus 2x minus 3. Right? It's a quadratic. Then you know the method to factorize. But now we need to use factor theorem. Okay? Because, right, we need to use the factor theorem. Right? Okay? So, right, how we are using the factor theorem? Now we need to do the rough work here. Right? We need to do the rough work here. So, okay, this is a rough work. I suppose this function fx x square minus 2x minus sorry, right? Now we substitute some value f1 1 minus 2 minus 3, right? No. Next f2 4 minus 4 minus 3, no. f3 9 minus 6 minus 3 r. Here we have f3. Right? Then we identify who becomes 0. Then we write it. Okay? Then we substitute this answer. Then we write this x square minus 2x minus 3. Substitute x equals f3. 3 square 2 times 3 minus 3. 9 minus 6 minus 3 equals. Therefore, right, f3 becomes 0. Right, f3 becomes 0. Then what is the factor? Factor is x minus 3 is a factor of fx. Okay. Then face the factors. Face the factors here? No. Right? Then how we identify the how many factors are there in the function? How many factors? Number of factors, how we identify? Yes. The maximum number of linear factors, right? It is linear. Okay, here also we can get the linear factors, right? Okay, so how we identify the number of linear factors? It is equal to the degree, right? Okay, it is equal to the degree, right? Okay, number of factors. Number of factors. They have one factor. Then how many factors are there? They only have two factors. It is quadratic. Their degree is 2. Now degree is the highest power of the x. The highest power of the x. Then, right, we call that number of factors equal to the highest power is 2. Then there is the x cube term. Right, they are x cube term. That's mean, right? Okay, number of linear factors are 3. Then we need to find the 3 factors. Okay, now we have one of the factor. We need to find another one. Right? Okay, another one. Now we substitute positive 1, 2, 3. Now we need to start in the right minus values. F minus 1. 1 plus 2 minus 3. Then we substitute minus 1. It's also is given the 0. Then we write it. After this, substitute x equal minus 1. If minus 1 equal minus 1 square minus 2 times minus 1 minus 3, 1 plus 2 minus 3, 0. Therefore, x plus 1 is a factor of fx. That is a way only be using the factor theorem, right? But okay, the question not state that okay only using the factor theorem we can use in the right okay any other method, right? But the first time we need to use the factor theorem. Okay, right? In the beginning we need to use the factor theorem. After that we can move to the right some method, right? Then we discuss later. Okay, right. Write down this. Doesn't need to show this, huh? Then I show you right how we identify the 0 terms. Okay, it's your word. Okay, finish. Okay. Right. Now we come to the second question. Now only you need to using the factor theorem, right? Only method factor theorem, right? No any other method. You need to identify three values, right? Three values, then function becomes zero. Hurry up. Hurry up. You need to factorize this. up. We need to substitute, right? Okay. Here we are. I write the rough work. Okay. Here I write the rough work. Okay. Then we substitute 1 is 1. 1 minus 2 minus 5 plus 6. What happened? Right? It's equal 0, right? Then 1 equals 0. Next, 1 given the 0. Then we substitute. Substitute x equal 1. Then f1. Okay? f1 equal 1 cube 2 times 1 squared 5 times 1 plus 6. 1 minus 2 minus 5 plus 6. Then it is 0. Therefore, x minus 1 is a factor of fx. Right? Then next value, we think 2 what happened is 8 minus 8 plus 10 plus 6. Right? Then 3, 27 minus 18 minus 15 plus 6. Then 33 and 33, yes, it's given. Then we substitute. Substitute x equal 3. Then f3 equal 3 cube 2 times 3 squared 5 times 3 plus 6. 27 minus 18 minus 15 plus 6, it's equal 0. Therefore, x minus 3 is a factor. Right? Now, we substitute minus 1. Minus 1. Here we substitute the minus 1. Minus 1, what happened? The minus 1, minus 2 plus 5 plus 6. No, ne? Minus 2, minus 8, minus 8 plus 10 plus 6. Okay? Then, here the minus 8, minus 16 and plus 16 is 0. This is. Then we substitute. Substitute x equal minus 2. F minus 2 equal minus 2 cube minus 2 times minus 2 square minus 5 times minus 2 plus 6 minus 8 plus 10 plus 6. Okay, it's 0. Therefore, x plus 2 is a factor. Next, now they have 1, 2 and 3 factors. Only we have 3 factors because they are power 3. Okay. What is that? That is a way only using the factor theorem. We need to know it very well. Okay. Make the corrections, hurry up. And I explain the method number 2. Right, method number 2 there. Because they have another method. Right, get these factors. Then we can using the long division and get the right remaining factors. Okay, let's see. That method we need to use in the questions. Okay, finish. Then we come to method number 2. Then write down, put this stuff. Okay, put this stuff, write down. Okay, write down. Here, 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 we find the first factor. Here we find the first factor. Using factor theorem, then we can divide the function. Then we can divide the function by here we find the first factor using factor theorem. Here we find the first factor using factor theorem. Then we can divide the function by that factor using long division. We can divide that factor using long division. Divide that function by that factor using long division. After using the quotient, there are factors we can find without using factor theorem, without using factor theorem, okay, right. Then I come to the method number 2. Okay, this is method number 2. Here we have fx is x cube minus 2x squared minus 5x plus 6. First of all, we substitute x equal 3 and we taken the first factor. Okay, therefore x minus 3 is a factor. Next. Now we are using the long division. Now we are using long division. That function divided by that factor. X cube minus 2x squared minus 5x plus 6 divided by the x minus 3. Divided by the x minus 3. Now what's happened? Now we are using long division, divide it. Here we put the x squared times x cube, x squared times minus 3 x squared. Okay. Now we take the subtraction, x squared minus 5x plus 6. Then we need to get the x squared, then it is x squared minus 3x. Then subtraction, minus 2x plus 6. Put the minus 2, minus 2x plus 6, remainder is 0. The remainder need to become 0, right? Because it's a factor. Now we can write the therefore fx. Fx is a divisor and quotient multiplication. X minus 3 and x squared plus x minus 2 multiplication. Okay. Now here we have a quadratic function. Then without the factor theorem, we can get the factors of that. X and x. So plus 2 and minus 1. Right? Plus 2 and minus 1. Okay, simply we can take the factors of this. Therefore, we write the factors. Factors are x minus 3, x plus 2 and x minus 1. Okay, this is need to substitute 3 values. Got it? Okay, got it there? Write down. That is method number 2. First of all, we find the factor. First factor using factor theorem. Then we using the long division, divide it and find the quotient. Right? There are factors given the all factors of the fx. Finish. Right. Now use that method. You need to get the factors of this. Fx equal 2x cube plus 3x squared minus 8x plus 3. Okay. Right. Now you need to follow the method number 2. Okay. Find the first factor. After that, using the long division, get the quotient, and you can get the easily factors of that. Who finishes? Okay, right. Then here we are. What is x? Then we substitute 1, 2, 3, 6, 10, 5, 8. Yeah. Maybe substitute x equal 1, we can get the C. F1 equal 2 times 1 cube, 3 times 1 squared, 2 plus 3 minus 8 plus 3. 0. Therefore, x minus 1 is a factor. Next. Now we are using the long division. 2x cubed, 3x squared minus 8x plus 3. When you have any doubt for the long division, I send the all recordings. Right, you can okay, watch that and clear your doubts. Here 2x cubed we need to get, then 2x squared we put here. Then we multiply the 2x squared and x, 2x cubed, 2x squared and minus 1 minus 2x squared. Then we take the subtraction is 5x squared, 8x plus 3 remain. Now we need to get the 5x squared. Here we put the 5x. 5x times x, 5x squared minus 5x. Here is a 3x plus 3 minus. Then you put the minus 3 there. Minus 3x plus 3 is 0. Now we can write the fx is x minus 1 and the quotient 2x squared plus 5x minus 3. Okay? Got that? Now we need to find the factors of this. Next, x minus 1. Now we can't write this one step. So 2 times 3 minus 6. Then we need to break in the middle term. Right? Here we need to get the minus 6. It's a 6 times 1. 6 and minus 1. Then plus 6x minus x minus 3. X minus 1. Here we take out the 2x. X plus 3. Here we take out the minus 1 x plus 3. Factors are x minus 1, x plus 3 and 2x minus 1. Okay. Now you can write the factors are x minus 1, x plus 3 and 2x minus 1. Okay. They have 3 factors. Now we can't take on the factor theorem, right? This factor 2x minus 1. Then we need to get the 2x minus 1. We need to substitute x equal half, right? Then we substitute x equal half. We can identify 2x minus 1 is a factor. But okay, we cannot take it using the factor theorem. Okay, right? That's why we need to use this alternative method. Okay, right? Got it that? Okay, then this is a right factor theorem. Right? Okay, they have some questions to solve. Right? Then that is right basic. Right? How we find the factors. Right? Of the function. Okay. So I given the questions to the group. Right? You need to follow that. Okay. Right? Got it that? Have questions? Have questions to ask? Yes. What happened? Right. Then like that you need to find the factors. Then I given the questions. Okay? Right? Then you can follow that and yeah. Okay? Here we have factor like that. We need to follow the second method. Otherwise we can't get the right that type of the factors. Okay? Right. So today we stop in class, right? Right? Okay, I given the instruction to right all of you, right? How to pay your fees, right? Of the Kampaha and also the Nigambo students, because we need to arrange online, right, payment rate, and also right, I say I explain how you can get the dues. Okay, right, don't doesn't need to go out. Okay, so if you right pay online, okay, then you need to send your right pay slip to me and also the institutes. Okay, then I explain it right in the WhatsApp group. Okay, then you check it, and also I arrange the right parents meeting this week. Okay, because I know you are right, most of the parents right with you now. Right, if you have a trouble, right, please let me know, right, otherwise, right, we need to arrange it. Okay, then I explain, right, to right parents the attendance of the online classes and the other thing. Okay, right, then stay safe. Okay, and if you have any question,